While you're busy relaxing on the weekend, entertaining, boating, chilling, and chomping, there's a whole fleet of people working in factories pumping out everything from candles to chairs, so you can sit back and enjoy the weekend. The science of manufacturing these items has evolved over time. What are some of the technologies that go into making the goods? Summer weekends just aren't the same unless you're hanging out with great friends, dipping your toes in the pool, and diving into some tasty snack food. And that perfect go-to guilty pleasure is popping open a fresh bag of chips. Potato chips were even declared an essential food item in the USA during World War II, so that production didn't have to stop. Despite the evolution of flavors taking some zany turns like chicken and waffles, the design of the chip has stayed the same since 1853. But it's advances in peeling, slicing, and packaging that makes potato chip manufacturing faster than before. Here in Detroit, Better Made Snack Foods has been pumping out chips since 1930.
Better Made Snack Foods started with two cousins, Cross Mosseri and Pete Cipriano. Back then, I think potato chips were still somewhat of a novelty. You could go out and buy a bag for a nickel.
Those potato chips were popular, but didn't have much of a shelf life. They'd lose their crispiness and become stale quickly. In the 1940s, innovations in packaging made it possible for chips to last past a day.
If you made the bag out of cellophane, ironed it over, and stapled it on the top, the chips would last longer, and therefore you could transport them further from where you fried them up. Today, we can put a potato chip in a foil bag that will be good to sell for 11 to 12 to 13 weeks.
The chip starts here with a load of fresh Atlantic or Snowden potatoes, specifically grown for the chipping industry.
We'll bring in 6 truckloads a day. Each truck has 50,000 pounds. It takes 45 minutes to unload each truck. All those potatoes equal about 17 hours worth of production time. And then at the end of the day, we'll clean up and do it all again tomorrow.
50,000 pounds equals about the size of a football field of planted potatoes. The potatoes head into the factory down a conveyor to the peeler. The factory peeled potatoes by hand until the 1950s, when the automated peeler was introduced. That state-of-the-art machinery revolutionized their output.
The peeler was something that allowed us to really process a lot of potatoes in a given day. And if you can imagine how long it would take someone to peel potatoes by hand and then to do the amount of potatoes we would need in a given day, you might have 200 people working 16-hour shifts in order to do that. The peeling unit is about 12 feet long, and inside are about 6 or 7 cylinders, and they have an abrasive material on it. If you were to touch them, it would feel like varying degrees of sandpaper. Basically grind off the peel of the potato.
A potato enters the peeler and comes out peel-free in 30 to 45 seconds. They're inspected for any defects before continuing in the process. Next, the potatoes head to the slicer. Each slicer has 6 to 8 razor-sharp blades and runs at 260 revolutions per minute. On average, it cuts 2,000 pounds an hour, or roughly 10,000 chips a minute.
As they fall through, they ride up against the edge, the inside edge of this brass wheel, and they will slice off a thin layer of that potato set to the thickness that we want it to be, and they will fall through into the wash basket.
The water bath takes the starch off the potato slices. Too much starch makes the chips hard and brittle and not very tasty. The slices are then picked up by rotating mesh drums and then blown dry by fans. The slices then fall into a fryer.
It'll have about 12 inches of oil in the bottom, and paddles move the potato chips down and through the fryer as they go. The oil is at about 350 degrees.
Since the beginning, Better Made has used cottonseed oil to fry their chips. The fryers can take in 12,000 pounds of potatoes an hour, equal to 4,800 bags of chips.
So that's more than 1 potato, 2 potato, 3 potato, 4.
The potatoes fry for about 3 minutes. Before the addition of these fryers, a worker would have to stand over the boiling hot fryer to stir the oil and scoop out the chips when they were done. In the 1940s, automated fryers took the labor and guesswork out of making perfect chips.
pouring out at about 2,400 pounds of finished potato chips an hour, and we're doing that 17 hours a day.
When the chips come out of the fryer, they are inspected yet again.
Bad chips like this, you gotta get them out here.
The good chips head up 20 feet via a bucket elevator. This is where they'll be seasoned. Today, they're making barbecue-flavored chips.
So one of the latest improvements is this barrel seasoner that we use. And what happens is the potato chips enter the one end of the barrel, and the seasoning is sprinkled on them as this barrel rotates. So the chips are getting a nice, even covering of the seasoning. This barrel that has allowed us to more quickly, more efficiently, and much more evenly season our potato chips than we were doing in the past.
The barrel has to be gentle enough not to break the chips. Seasoned chips then fall onto a scale.
The potato chips slide off the cone and they fall into these buckets. There is a computer that is weighing each one of these different buckets. It will look for the 5 or 6 different buckets that get the exact weights, and it'll open up and they will fall down into it.
Then, the measured chips get packaged into bags that are made from printed rolls of film. The bags are carefully boxed and sealed, and then put on a conveyor belt that travels to the warehouse and out the door.
Well, on an average day, we will make about 10,000 cases of product.
So, it's the invention of the barrel-shaped peeler and seasoner machines that have helped pump up mass production of delicious potato chips. Now, how does this barrel shape at another factory produce candles that help light up your weekend? When it comes to setting a great weekend party mood, glowing, flickering candles are one way to do it. Everyone has had fun making candles at home. It's a popular hobby that's pretty simple to do. But here at the Yummy Candle Factory in Mississauga, Ontario, they've invented some high-tech steps to produce candles faster. Every candle starts out as melted wax. Traditionally, candles are made with paraffin wax, a non-renewable oil-based product. But Yummy makes their votive-style candles with environmentally friendly wax.
A BioLight candle is made out of 100% vegetable wax, and it's renewable and sustainable.
But it's not just the wax itself that's an improvement on old methods. In the past, candles were shaped purely out of liquid wax. Today, with state-of-the-art technology, these particular candles are a combination of a solid wax and a liquid wax. The solid portion allows the company to make more candles per shift, and the liquid portion allows the wax to fill the glass vessel and take its shape. The first step is converting hot liquid wax into solid fine granules. This is known as the cold press process.
We want to cold pressing so we can be more competitive, so we can produce millions of candles instead of hundreds of candles a day.
This massive machine is the granulator. Hot liquid wax is pumped through pipes, sprayed up into the air, and falls into a rotating chilled cylinder. The cylinder is hollow and is chilled by 10 degrees Celsius water, circulating around inside it. The liquid wax cools down on contact with the spinning drum and produces small granules of wax. The drum can produce up to 900 kilograms of powdered wax per hour, about 4,000 cups of hot coffee. The cool, sugar-fine granules fall into a bin, and they're checked to make sure they're fine enough. From the granulating machine, full bins are wheeled out to the production floor. The cool granules of wax are sucked up into a hydraulic-powered press, which presses them into discs. 13 grams of wax makes 1 disc, and the rotary press can make 750 discs a minute.
If you take a candle and you put it in your palm and you squeeze it, and if it doesn't break, that means the candle is compressed well. If it breaks, it needs more compression.
Forming candles this way is faster, since it eliminates the setting time that used to be required to let the wax cool. That means instead of making hundreds in a day, the company can make 30,000 BioLights in a 24-hour shift. But every candle needs a wick to help burn it. Yummy uses wicks made out of cotton. Wicks have been made out of everything from paper to reeds in the history of candles. But cotton fibers make a strong, slow-burning wick that's easy to make into different lengths. The long strands of cotton are fed into the machine and dipped through wax baths.
It passes through 9 holes, and as the holes pick up the 78-degree wax, it coats it and becomes a specific thickness.
And the thickness is what stabilizes the threads. It also means that the flame will be consistent and help eliminate any smoke or soot that might want to escape. The coated wicks then go to meet the compressed discs. This machine punches a hole into the disc and threads the wick through. A small metal disc, called a sustainer, is pressed into the bottom of the candle. Without a sustainer, the flame could heat the glass vessel and crack it. Next step is down the conveyor to the pick-and-place machine. It grabs each cold-pressed candle one by one and places it into a glass holder. They head through another conveyor and are lined up at the filler. Here, 15 grams of hot wax are poured into each holder to level off the top, secure the candle, and make it look pretty. Before the addition of a cold-pressed disc, this candle style was made with liquid wax, which took a long time to dry. So now, less liquid equals faster drying time. The hot wax cools off, and 10 minutes later, the candles are ready to be packed. Yummy makes 625 cases a day. If you stack them on top of each other, it would equal a 29-story high building. Some of these candles head for a quality check. The candles are lit in a burn room. The average lifespan for this candle is 8 hours.
The burn test looks at things like flame height, glass temperature. We come back every hour and we check for these same characteristics to make sure that the candle's burning properly for safety reasons and for overall quality of burn.
The invention of a drum machine that cools and converts liquid wax to a solid fine powder wax is key to the fast mass production of votive candles. And it's the technology of another type that heats up and reshapes a plastic form into a bottle. Perfect for quenching your thirst on the weekend. Hot summer weekends, great friends and great times. And a cocktail hour or two is the perfect way to kick it off. And with advances in plastic technology, all you have to do is add ice and voila! You've got a chilly beverage ready to go. The Blackfly Beverage Company in London, Ontario has been in the drink business for the last 10 years.
Blackfly makes blended spirit beverages, so vodka, tequila, rum, and whiskey mixed drinks.
We use tequila from Mexico. We use whiskey from Canada. We use vodka from Canada. We use rum from the Caribbean.
All these alcoholic ready-to-go drinks start with filtered water, which is poured into these mixers. The water is then heated so it will dissolve all the dry ingredients, like real cane sugar. Next, the signature juices are added. This is a batch of Long Island iced tea with pure lemon juice. Once it's all blended, both the mix and the alcohol are pumped into 2,000-liter stainless steel tanks. That's the easy, straightforward part, not too different from mixing up your own batch of Long Island iced tea at home. But what makes Blackfly coolers stand apart is the next step, bottling the liquid. A lot of pre-made drinks are bottled in glass, but those break easy and aren't super cottage friendly. To solve that problem, the company uses plastic. These bottles are made from PET plastic, a non-toxic, lightweight, highly recyclable food-grade plastic product.
Well, our bottle making process is called reheat, stretch, blow molding. We're basically manufacturing our own bottles on our line. There are a lot of places where glass is not welcome. Rocks, docks, poolside, beach.
Non-breakable bottles are phenomenal for just making life easier. It's so easy to pack, it's lightweight to carry, drops on the ground, doesn't break, beautiful.
Each bottle starts as an injection molded preform with the signature wide mouth already formed. They came up with a larger mouth size so that ice cubes could slip in easily and cool the drink quickly. The company brings in over 6 million preforms per year. The preforms are loaded into a hopper and the machine pulls them up. Robot arms place the mouth down onto nozzles. Then, the preforms are sent through a heat tunnel, which heats them to 100 degrees Fahrenheit. This softens the plastic, so it's ready to be stretched and reshaped. The heated plastic goes into the mold. Air is blown into the preforms at 550 pounds per square inch until the molten plastic is forced to form the signature bottle shape. It goes in looking like a totally different shape from when it comes out. The blow mold can make 33 bottles per minute. The bottles are flash chilled inside the molds, so when they come out, they are completely solid.
And then the mold opens up and the bottle pops out and it's ready to be filled.
The bottles are placed onto a conveyor and go to the filling section, where they're rinsed with filtered water. They travel down the line, where this rotating head grabs them and puts them in the filler. The liquid is pumped into each bottle by the counter pressure filler. This type of technology was developed for the carbonated beverage industry. The 8-head filler can fill about 33 bottles per minute, 1,980 bottles per hour, or 47,520 bottles per day. Black screw caps funnel down from a hopper onto the machine, which grabs them individually and screws them onto each bottle. The bottles are then rinsed and labeled as they head down the conveyor. At the end of the line, the bottles are quality checked to make sure that they've been properly filled and the caps and labels are secure. It takes under a minute for a test tube-shaped preform to be blown into a bottle, rinsed, filled, capped, and labeled to emerge as a bottle of Black Fly. Next, the bottles are packaged by hand in groups of 4.
We roughly do a 4-pack every 6 seconds. I like to go quicker than that.
6 4-packs fill a case, and then it's taped and stacked. The company produces 1,500 cases a day, enough for 36,000 guests. That would be one fun party. So it's new advances in machinery that reshape and reform recycled plastic to help you wet your whistle on the weekend. And you'll never guess how recycled plastic is used in a way that means never wasting time on your weekend painting or staining a wooden chair. Everyone knows this classic Adirondack chair with its inviting seat and wide armrests that scream out for a drink. It's a perfect chair for lounging, especially on long, lazy summer days. Backtrack to 1903 in Upper New York State. Fed up with stiff, uncomfortable chairs, an American named Thomas Lee invented the first wooden Adirondack chair. But wooden chairs are high maintenance. Exposure to sun, rain, and snow rots the wood so that they need constant repairing, repainting, and restaining. In 1994, Jamie Bailey of Canadian Recycled Plastic Products in Stratford, Ontario, hit on a revolutionary idea. He started constructing Adirondack chairs out of lumber made from low-maintenance, recycled plastic products.
You just don't have to paint it, stain it, or put any chemicals or anything to preserve it. As soon as I made the first chair, I said I'd never work with wood again.
Jamie's improved lumber starts with recycled plastic products. Things like orange juice containers, shampoo bottles, and plastic bags will be shredded down to bite-sized pieces.
Everything you see behind me would have ended up in the ocean or the landfill, but they're here to be made into chairs.
The giant bales of plastic weigh 1,100 pounds. The wires are snipped and they're divided into hoppers. It takes about an hour for the shredder to cut down one bale of plastic. It then goes into the grinder, which turns the plastic into snowflake-sized pieces. But sometimes you can still tell where it came from.
This one, vanilla. Must have came from ice cream crates.
CRP makes 18 different colors of lumber. The ground-up plastic is blended with the color pellets. Exposure to the outdoors and ultraviolet radiation can cause the color to fade, so a UV stabilizer compound is added to make sure the color holds fast in the bright summer sun.
When I started the company, I was more into the environmental issue of having it being a recycled plastic chair. And the maintenance-free was just a bonus. After we built them and had them sitting outside for 5 years, it was that they still looked the day like you bought them.
The mixed plastic is fed into an extruder, which is a machine that melts plastic into a liquid and pushes it through a die or into a mold to shape it. Although you can't see it, the extruder has a large screw inside a heated barrel. The plastic is melted at over 300 degrees Fahrenheit as the screw pushes the molten plastic through. The liquid is then squirted into molds, which shape the melted plastic into various sizes of lumber. After the plastic is set in the molds for about 10 minutes, it's removed by hand, piece by piece, and set aside to cool and harden for 24 hours. And just like real wood, the pieces are taken to the precision cutting department.
This is our CNC4. This is our newer machine that had 2 heads. Means we can do twice as many chairs, twice as fast.
CNC stands for Computerized Numerical Control, and it's a specialized machine that perfectly cuts and routers each plastic board into one piece of the chair. Each cycle takes about 4 minutes. Without this machine, each piece would have to be cut and shaped by hand.
When we originally started out, everything was made by hand. We had no CNCs, no robots. We didn't even have extruders.
But with a public hungry for durable outdoor furniture, CR Plastics had to expand their automated assembly line to keep up with demand. In 2010, they bought robotic machinery. The chairs are assembled by robots, which drill, countersink, and set the screws for the seats and backs of each chair.
There's over 30 pieces that go to making a full chair.
Before they got the robots, they were only producing 3 chairs in 1 hour. Now, in the same amount of time, robots can screw together pieces for 20 chairs. The factory produces hundreds of chairs every day. The chairs are now in 5 pieces, which allows for convenient packing and easy assembly for the folks at home. And the less amount of time you have to work, the more time you'll have for fun on the weekend. Thanks to the latest technological advances in manufacturing, our weekends are that much more fun.